What's up, everyone? Today we're going to talk about probabilities. So let's get into some basics first. So probability, as we hopefully know by now, is the likelihood that an event will occur. An event that has no chance of happening, it's impossible that it's going to happen, is assigned a probability of 0, versus an event that has a 100% chance of happening, that it's certain it's going to happen, is assigned a probability of 1. All other events can then be assigned a probability between 0 and 1. It's also important to note that probabilities are fractions or decimals between 0 and 1 inclusive, versus percentages are between 0% and 100% inclusive. So if we ask for a probability, you should be giving a fraction or a decimal. If we ask for a percentage, you should be giving a percentage. All right, so we're going to talk about two main types of probability. One is experimental, which comes from observing the results of an experiment, and it's also called relative frequency. The other one is theoretical, which is based on what we theoretically expect to occur, and it measures the chance of an event occurring in any trial of an experiment. First up is experimental, and we're going to look a little bit more about its vocabulary. First up, we have trials, which is the number of times the experiment is repeated. The outcomes, which are the different results possible for one trial of the experiment. The frequency is the number of times a particular outcome is observed. And then the relative frequency, like we just said, is the probability. In general, the greater number of trials you perform, the more we can rely on our estimate of that probability. All right, so let's look at an example. A cone is tossed into the air 279 times. It fell on its side 183 times and on its base 96 times. And we're being asked to state the trials, the outcomes, the frequency, and the relative frequency. Some of the trials is how many times was that experiment performed? And in our case, that is 279 times. The outcomes are the possibilities of the experiment. So it can fall, this cone can fall on its side, or it can fall on its base. So we have two different outcomes, which also means we're going to have two different frequencies. So the frequency of the side, how many times did it fall on its side? It fell on its side 183 times. And the frequency of the base, it fell on its base 96 times. And similarly with the relative frequency, we're going to have two different answers for that as well, one for the side and one for the base. So for our side, we're taking our frequency of the side and dividing it by how many total trials there were, so 279. So we want this, it's not specific for how they want the answer, but we want to at least simplify this fraction, which it can be simplified to 61 over 93. We can also give it as a decimal though, which would be 0.656. I'm going to leave it as those two just to kind of get us in the habit of putting the probability, since I'd already said experimental probability is the same thing as relative frequency. Since this one didn't specify, you could say 65.6% as well. For our base, we'll take our frequency, 96, divided by the total number of trials, 279. And again, simplifying the fraction at least to 32 over 93, or writing it as a decimal of 0.344, or 34.4% is also fine. Talking a little bit about sample space. Sample space is the set of all possible outcomes of an experiment, and it can be given as a list, as a table, or a tree diagram. So for example, if we have two coins that are tossed, we're asked to represent the sample space for this experiment by making a list, a table, and a tree diagram. We can let H equal heads and T equal tails. So for our list, you're just literally listing out all of the possibilities. So if I'm flipping two coins, I could have two heads. I could have the first one heads, the second one tails. I could have the first one tails, the second one heads, or I could have two tails. So you're just listing out those possibilities. For the table and the tree diagram, they help more when you're looking at multiple experiments at the same time or multiple trials at the same time, or depending on what the outcomes are, maybe multiple outcomes at the same time. But for our table, we can make it look kind of like those multiplication tables that we used to have. And I can have one coin on the row, one coin on the top column. So I have my heads and my tails for each of those, and then just matching up the heads and the tails for each possibility. So again, what's in red is my actual sample space, and you're just using the table to help you get there. Finally, with the tree diagram, same kind of deal, that we're going to have tree diagrams are kind of like those branches that go out. That helped at all. But so with our tree diagram, we'll have one branch being the first coin. So when I flip that first coin, it has two options, a heads or a tails. When I flip that second coin, I still have the two options, a heads or a tails. And to get your actual sample space, you're following along each of those branches. So I could have two heads in a row to get my double heads. I could have a heads then a tails to get my heads tails, or tails then heads, or two tails together. We're going to talk more about tree diagrams in a future lesson. When you're finding the expected number of times that a die will show whichever question you're looking at, you're taking the probability, multiplying it by the number of trials.